In today's lecture, we will discuss about periodic signals and aperiodic signals. Right? So, for the periodic signal, the condition should be satisfied for signal x of t, the condition to be periodic, x of t must be equal to x of t plus some t value. If the equation holds like this, x of t equal to x of t plus t, then the signal is periodic. So let us consider an example, a signal like this. So consider a sinusoidal waveform which is existing from minus infinity to plus infinity. So one basic condition that should be satisfied by the periodic signal is the signal should exist from minus infinity to plus infinity. Okay, so if you shift either right side or left side by a value of t, so by a value of t, if it holds the same structure for that shift, then the signal is periodic. That is, if you shift right side the signal by the time t or the left side by the time t, if the shape of the signal, the shifted signal, which is x of t plus t, is equal to x of t, then the signal is periodic. It indicates that the structure will be same if it is shifted by a time t. Okay, so here we will discuss about the two cases. One is, not exactly two cases, 2 points. One is period of a signal and fundamental period of a signal. Fundamental period of a signal. So what is period of a signal? What is fundamental period of signal? So the fundamental period is the least value of t. That is, so I can take this shape is held, or this shape, this point to this point is t, this time is t, and for the same time t, the shape, this same shape again repeats. So this is the period of the signal. The same, I will say that I consider another one, the like, so from the point, this point to, okay, not exactly this point to this point, so let us see. So I take this point to this point. This is also period of the signal. Why? Because again the shape was repeating like that. So if I continue drawing like this, okay, so now here I will take the value from this point to this point, and I take this one as t, some t1. Okay, so this point to this point, so this t1, if you take the another t1, if the shape is the same like this, and that's also period. Okay, t is also the period, that is from this point to this point. T is the period of the signal. T1 is also the period of the signal. Okay, like if you take another wave, okay, another time t1, that is t, 2t, 3t, 4t, all these are the periods of the signal. Periods of signal. Okay, so the shape in the duration of time t repeats once again, okay, or the shape in the duration of 2t repeats again for the next 2t and for the next again 2t. The shape in the duration of 4t repeats again for the next 4t. So if it happens like this, it's obviously it's a periodic signal, and these all are the periods of the signal. Say t is the period, 2t is the period, 3t is the period, 4t, like this 5t and t. Okay, these are the periods of the signal. So the fundamental period is the least possible. So t is the fundamental period. So you should differentiate the period of a signal and the fundamental period of the signal. Then same thing holds for the discrete case also. In the discrete case, x of n equal to x of n plus capital N. So if it holds, then x of n is periodic. If not, it's not a periodic signal. Simply it's an aperiodic signal. Okay, from minus infinity plus infinity, the signal will exist and the structure will be repeating for every t, where t is the period of that signal. Okay, so let us solve some basic problems how to find out the period of a signal. Okay, so we take an example considering that a simple signal x of t equal to cos 10t, cos 10t. You compare it with cos omega naught t. So omega naught is 10, which is 2 pi by t naught is 10, and t naught is 2 pi by 10, which is pi by 5. So the period is for the signal is pi by 5. Okay, it's a periodic signal. Obviously, you know that cos signal is a periodic signal. And what's its period? The period is pi by 5. The fundamental period. Okay, the fundamental period is pi by 5. Okay, so let us see the next one. So if x of t is a combination of two signals like cos 10t plus sin 4t. Okay, in such cases you have to find out the individual periods of these two signals, cos 10t and sin 4t. So period of this cos 10t, that is t1 equal to pi by 5. Okay, as you know about it. And for this t2 is, okay, 2 pi by 4, which is pi by 2. So what we have to do now? So we have to check the common period. What is the common period of the signals? Cos 10t plus sin 4t. So for this one, first we have to do whether it is the periodic or not. So you take the ratio of t1 and t2, which is pi by 5 and pi by 2. So obviously it is 2 by 5, it's a ratio of integers. Okay, if t1 by t2 is ratio of integers, then x of t is periodic, is periodic signal. So we concluded that the ratio of t1 and t2 is the ratio of integers. Okay, it's a ratio of integers. So with this conclusion you can say that x of t is periodic signal. But what is the period? Okay, what is the common period of this? So for that one, t is LCM of t1 and t2. So consider LCM of t1 and t2. Okay, and the t is your the common period, the period of signal x of t. So for this one, so for calculating the LCM of these fractions, t1 and 2 both are fractions. So for this one you go for LCM of numerators and HCF, highest common factor of denominators, that is LCM of pi by 5 and pi by 2 is LCM of numerators, that is pi, okay, and highest common factor of the denominators is 1, okay, LCM of pi and pi, okay, and HCF of 2 comma 5, highest common factor. So this is pi and this is 1, so the value is pi. So the period of the signal x of t is pi. Okay, I hope this one is clear for you, right? So let us check another thing. E power, sorry, x of t is e power j t plus pi by 4. Okay, so this is the comparison with for j omega t plus pi by 4, not pi by 4, you write it as an phase. Okay, so e power j omega t plus 5 simply. So you compare it like this, omega equal to 1, so 2 pi by t is 1 and t is 2 pi. So it's a periodic signal. Okay, x of t is periodic with t equal to 2 pi. Okay, and one thing you have to remember, that this complex exponential signals like e power j omega t is always periodic. Okay, it's always periodic. So if you expand this one, cos omega t plus j sin omega t, if you plot the signal with respect to time, okay, the real part and imaginary part, okay, cos omega t, it's a cos signal, and sin omega t, it's a sinusoidal signal. If you check the strength of this one, I mean the plot the strength, the value will be 1. So if you observe the 3-dimensional plot of this e power j omega t, okay, or cos omega plus t plus j sin omega t, the signal will be like this one. Okay, and this is the signal of a complex exponential signal. So if you plot the cos omega t and sin omega t, or else if you plot e power j omega t, the plot will be like this one, this blue color. So this blue color plot is the plot of e power j omega t, and this green color and this red color are the envelopes or impressions if you observe on this planes. Okay, so you observe here, this is the imaginary axis. Imaginary axis envelope is sin omega t. Okay, sin 0. Okay, what sin 0? You can go for this 0. Okay, sin 0, the value is 0 here. Okay, the value is 0. The value is 0, right? So this one is the imaginary signal plot. Okay. If you go for this another view, okay, if you go for another projection, you can observe the real part. Okay, the real part is your cosine. So observe this here, cos 0 is 1. You can get the value like this. Okay, cos 0 is 1. So if you observe that plot from the front view, okay, it will be a circle. It will be a circle. Okay, you can observe this one is an like helical structure, like spring like structure, the waveform or the plot of this complex exponential. So this is the circle of radius 1 that gives the strength of your sun. Okay, so this one is the front view. Okay, one view you will get sine waveform, in another view you get cosine wave, right? Okay, so that's why this one is always a periodic signal. Okay, so you take another example, e power j t plus pi by 4 again, and but it's multiplied with u of t. Okay, you know that e power j t plus pi by 4, it's periodic, but this is not periodic. Why? Because this starts from at 0 and goes up to the infinity in positive time. It doesn't exist in the negative time axis. Okay, so if you multiply this signal, you won't get a periodic signal. So the combination of ut and e power jt plus pi by 4, it's not periodic. Okay, right. The same, if you observe in the discrete case, discrete signals like cos 0.1 pi n. Okay, cos 0.1 pi n. You observe this omega naught equal to 0.1 pi. Okay, omega naught is 0.1 pi. So here you should take that omega naught by n. Okay, so omega naught by n, omega naught by 2 pi should be a ratio of integers. Okay, omega naught by 2 pi should be a ratio of integers, that is omega naught is 0.1 pi by 2 pi. Okay, that is m by n. So m by n is I will write it like this, n by m is simply at 20. Okay, so the period n is 20. So for the, you can take 20 into m for the least value. Okay, n takes the smallest positive integers when m equal to 1. So when m equal to 1, n takes smallest positive integer. Okay, n takes the smallest positive integer. So n equal to 20 is the period of the signal, period of the sequence cos 0.1 pi n. Okay, so I will give the clarification regarding this, why we should take like this. So what is m, what is n, all these things. So I take a signal, a general signal, e power x of n equal to e power j omega naught n. Okay, so we have to check whether it is periodic or not. you know that x of n equal to x of n plus n. If it satisfies, it's periodic. Okay, it's a discrete complex exponential signal. Okay, e power j omega naught n is a discrete complex exponential signal. So write it as j 2 pi f naught n equal to e power j 2 pi f naught n plus capital N. I am expanding about this. Okay. So e power j 2 pi f naught n and e power j 2 pi f naught capital N. So to be equal to the right hand and left hand side, this should be equal to 1. Okay, so e power j 2 pi f naught n is periodic if e power j 2 pi f naught capital N is equal to 1. So this occurs if f naught n, okay, that is f naught n is integer. Okay, this one. This value should be an integer. Okay, to make it as an 1, that is f naught n should be equal to k. So f naught equal to k by n. So in the above problem I have taken as m. So okay, for our convenience I will take m here. So f naught equal to n by m. So what is f naught? F naught is omega naught by 2 pi. So omega naught by 2 pi should be equal to m by n. Okay, so if it satisfies, I mean if this condition is satisfied, that is if m by n is an rational number, okay, if m by n is a rational number, then above signal x of n is periodic. That x of n means your e power j omega naught n. This is periodic. Okay, so that's why we are representing we are representing that omega naught by 2 pi, which is equal to m by n. So let us solve some other problems for the calculation of these things. Let us take the discrete signal, discrete complex exponential. Okay, take e power j 6 pi n. So you compare it with this e power j omega naught n. So omega naught equal to 6 pi, and so what we have to do, omega naught by 2 pi should be equal to m by n. So this is the condition we have to remember. So 6 pi by 2 pi equal to m by n. So what you will get, you are getting m by n, which is equal to 3. So n is equal to m by 3. Okay, so n value is equal to 1. Okay, for m value 3. Okay, for m equal to 3. So the least possible integer, n value is 1 for m equal to 3. So the above signal is periodic with n equal to 1 for m equal to 3. Okay, so let us take the combination of two signals, e power j 2 pi by 3n plus e power j 3 pi by 4n. It's the same as in the continuous time. You go for the calculation of n1 and n2. Okay, n1 and n2. So what is n1 and what is n2? So here omega 1 is 2 pi by 3 and here omega 2 is 3 pi by 4. So again omega naught by 2 pi equal to m by n. Okay. So omega 1 by n1 equal to m1, not omega, omega 1 by 2 pi equal to m1 by n1. So what is omega 1? 2 pi by 3, 2 pi equal to m1 by n1. So n1 y by m1 equal to 3. The same omega 2 by 2 pi equal to m2 by n2. Okay, omega 2 is 3 pi by 4 by 2 pi equal to m2 by n2. So here n2 by m2 is 8 by 3. Okay, and here n1 is 3 and n2 is 8. So we got n1 3 and n2 8. So we have to calculate the n, the common value. So take again the LCM of n1 and n2. Okay, n is LCM of n1 and n2. So the LCM of 3 and 8 is 24. So n is 24 for this. Okay, so I hope this one is clear. Let me go for the last example in this category of signal. So cos 20n, the same omega by omega naught by 2 pi equal to m by n. So compare it with cos omega naught n. Omega naught by, so omega naught is 20. 20 by 2 pi equal to m by n. So what I am getting here? So n by m is pi by 10. Pi by 10. So this thing, so this one is not ratio of integers. Okay, so cos 20n is aperiodic signal, right? So I hope these 2 points are clear for you. I mean the calculation of the periodicity for the continuous time signals and the discrete time signals. So it should be crucial while finding out the periodicity of the different combination of signals, right? Thank you.